Hello, welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of a series of videos on Venn diagrams, and in this video I'm just going to be talking a little bit about the theory, and I'm going to give you a little hack to explain which sections of the Venn diagram that you're going to be looking at. So what I've got on screen at the moment, I've got four Venn diagrams drawn with event A and event B, and what I'm just going to start off by doing is just identifying which sections of that Venn diagram you want, depending on the notation that you've got here. So if we just start with this one up the top left, we've got A intersects B, so that's A and B both happening. And then we've got here A union B, which is A or B, or indeed both happening. Now, there's a nice little way, a nice little hack that you can use to work out which section of the Venn diagram you're looking at for each of these two scenarios. So what I'm just going to go purple here. I'm just going to put, for A and B, I'm going to put a tick in the two sections that are A, so that's this bit and the bit in the middle. And then, because my other event is B, I'm going to put a tick in anywhere that's B. So B is there, and B is also in the middle. Now, anywhere where you put two ticks is the intersection, and anywhere where you put any ticks at all is the union. So the intersection of A and B is that bit in the middle, and the union of A and B is anything inside those two sections. Seems fairly obvious for just A and B, but it's really useful tip when you get onto things like not A and not B, which I'll just do quickly for you now. So top right, I've got not A and B are my two events that I'm interested in. So first thing, I'm going to tick the two sections of the Venn diagram that are not in A. So that's this bit that's just in B, and the bit that's outside. My other event is B, so I'm going to tick the two bits of the Venn diagram that are in B. So that's this bit and the bit in the middle. Two ticks is the intersection, so there's my intersection of not A and B. Anywhere where there's a tick is the union. So the union of not A and B is this middle section, just B, and the outside. Same logic applies down here. I've got two events, A, not B. So let's start off, tick the two sections that are A, there and there. Tick the two sections that are not B. So there's the bit that's just in A, not in B, and then the bit on the outside. There's the intersection, the bit that's just A, and there's the union, anywhere that's got a tick in it. Everything except the bit that's just B. So far, so okay. This is the bit that people tend to really get confused about, the not A and not B. They tend to be pretty happy with the intersection of not A and not B. That's obviously the bit outside, so it's not A and it's not B, but the union often confuses people. This little hack sorts that all out. Let's tick the two bits that are not A. There's that bit in B and the bit outside. Let's tick the two bits that are not B. There's the bit that's just in A, and there's the bit outside. There we go. As discussed, two ticks for the outside bit, the intersection of not A and not B, but the union of not A and not B is these two sections here and the outside section. So everything except the centre intersection of A and B is in the union of not A and not B. So if you're ever in doubt, you try and do a probability question from a Venn diagram and you're not sure which bits to use, tick the bits of the two things you're interested in. Where you've got two ticks is the intersection, where you've got any ticks is the union. Right, stay with me. I'm just going to do a little bit on the formulae that you need when you're working with a Venn diagram. There's one about A union B, and then there's this one which is the conditional probability formula. I'll talk about that in a minute. But I'll start off with this one, the probability of A union B. Now this is a formula that you're given in the formula book, so I'm just going to jot it down and then I'll explain how and why it works. So, probability of A union B, which you'll remember from above is everything inside these two sections, is equal to the probability of A plus the probability of B minus the intersection of A and B. Now, the reason that happens is if you add up all of A and you add up all of B, you've counted the bit in the middle twice, which is why you need to subtract it to find the union. And that formula, when you've got the information in the Venn diagram, that formula is not very useful, but if you're given some information, maybe three parts of this, you can use it to find out other parts, other values within the Venn diagram and use it to fill out the rest of it. We'll do a problem like that in the next video. I'm just going to talk a little bit about this conditional probability formula. Now, this one here means the probability of B happening given that A has already happened. So that's the important thing. A has already happened. Now that means we're only going to be choosing out of this section that's event A. So that's what it's out of. So straight away the denominator of my fraction is going to be the probability of A, because that's the bit in the Venn diagram that we are looking for. Now the probability of B happening, given that A has already happened, we're only allowed to look in this section. The probability of B is this bit here in the middle that's also B, given that A has already happened. Now that is the intersection of A and B, or B and A. I've written it that way around for the purpose of reversing the formula in a second. So it's the intersection, it's A and B both happening, given that A has already happened, out of the probability of A. Now the bonus of this formula is that you can take this basic one, and whatever you're given, you can just fill in the gaps. Now, what I mean by that is, if you wanted to work out the probability of A given B, all that would happen with this formula is, it would be the probability of A intersects B on the numerator, and the probability of B on the denominator. So the given that bit is always what ends up on the denominator. That's what the probability is going to be out of. There's one final bit with this, and it's to do with independence. Now, if two events are independent, so I'll just deal with this bit first. Probability of A given B. Well, if A and B are independent, it wouldn't matter whether B had already happened or not. The probability of A would just be the probability of A. It doesn't matter whether B's happened or not first. So, that left-hand side of this formula just becomes the probability of A, because it's not dependent on B. However, it's still equal to the probability of the intersection of A and B over the probability of B. And what I can now do is, if I multiply across by the probability of B, I can arrive at this very useful formula, which is that if A and B are independent, then the probability of A multiplied by the probability of B will equal the probability of the intersection. So all of this multiplied by all of this gives you the bit in the middle. It's a very useful result that we'll use in a future video, and I'll see you then.